everyone, and welcome to our webinar, Think Like an Adversary. Identify and visualize potential breach points with the attack path analysis. During the webinar, we'll present a live demonstration of the attack path, which is a dynamic interface that illustrates potential vulnerabilities through attack paths. During the webinar, we will discuss the fundamentals of the attack path and its benefits in your company's security strategy. We'll provide a detailed examination of the attack path components, and we'll discuss reachability and exploitability. My name is Raviv Vinnik, and I'm a product manager at Ox Security.
Hey everyone, my name is Itai Ganzer, and I'm an engineering manager here at Ox Security.
Yeah, so me and Itai will run the webinar together, and we will start our webinar by providing some background about the attack path and the challenges customers face that are being addressed by the attack path. Then I will start from the background. In the last years, there has been an exponential growth in software supply chain attacks, and I will mention some of the reasons behind this growth. First reason is that attackers have become more skilled, and the tool they use for initiating attacks have become more sophisticated and more easily available. Another important reason is that AppSec teams find themselves overwhelmed by the complexity brought on by rapid development cycles and the nature of modern applications, including APIs and cloud environments. So till now, I described the challenges, and now let's get to the solution which is required. And the solution which is required is having a systematic, actionable approach for understanding and mitigating attacker behaviors and techniques. The solution that me and Itai will go over provides the ability not only to see, but only to understand the attack paths that attackers might exploit, and this involves adopting an attacker mindset. The solution that me and Itai will go over enables AppSec team to differentiate between critical issues to issues that are less critical, as well as to issues that are merely hygiene issues. And the solution is, of course, the Ox Security's attack path. The attack path integrates applications, APIs, and cloud context with the function call graph. The attack path addresses security concerns across code, APIs, and cloud by visualizing and mapping those attack paths and providing evidence that allows users to view security from an attacker perspective and prioritize critical reachable issues. Now, I would like to hand over to Itai to tell us about the most common challenge that we heard during our ongoing discussions with customers and prospects, a customer challenge that is being addressed by the attack path. Itai, the floor is yours.
Thanks, Raviv. One of the most common challenges faced by application security teams today is getting the development teams to acknowledge and address security issues. Often, developers underestimate the risk or dismiss the issues based on information that isn't always visible to the application security team. When both development and security teams have complete insight into the application's lifecycle, it promotes the transparency and accountability for both. This enables AppSec teams to provide concrete evidence of the severity of each security issue, facilitating a more collaborative approach to resolving them.
Thank you, Itai. And now we go to the part of the live demo of the attack path. And I will show my screen, the Ox Security's issues page. And what I will do now to make the demo more interesting, then I will use a filtering, filter by code to cloud exposure to be directly exposed to the internet. And I will also filter by exposure by API exposed. And I see here a list of 24 issues, and I will pick the first one in the list. And I will click on its attack path tab, and we'll open it in full screen. So you can see here the issue name in the left side. Below that, you can see the description of the issue, the recommendation for the issue. And in the upper part, you can see actions that can be triggered on this issue directly from this page. Actions such as create Jira ticket, send Slack message, and more. So what I will do right now, I will start the live demo by a quick scan of the attack path left to right, just a high-level overview of it, and then me and Itai will do together a slower deep dive of the attack path components. So let's start the quick scan. Here you can see a node for the issue. On the right of it, we can see a node for the application, nodes for APIs exposing the issue, a node for Amazon ECR, nodes for Kubernetes clusters, nodes for cloud accounts, the node for the internet, and next to it we see the exposure of the issue status, and we see node for SaaS services. That was just a quick scan. I'm just turning to the left, and we will right now start the slower deep dive of the attack path and its components. Here, for the issue node, we can see the issues category. It's an open source security issue. Its severity is high, and the issue node is surrounded by info nodes. To the left of it, there is a node which is called detection and response. And let me expand it. It provides information about the issue owner, commit-related information, such as the file that was committed, when it was committed, and by whom it was committed. And the user can click and see more details. And also, we have here information about when was the issue first seen by Ox. Here it's about 2 months ago, and also here I can click and get more details. Above the issue node, we have the severity factor nodes. And I will expand it as well. And we can see that this issue have several severity factors, which are grouped by reachable, exploitable, and damage. And the user can click each of the severity factors and gets its description. We can see a red icon pointing above that lets us know that those are severity factors that increases the severity. If we would have here severity factors that reduces the severity, it would have been a green icon pointing down. Below the issue node, we have a node which is called intelligence nodes. And Itai has the credit for the name of this node, and I will expand it as well. And it shows a lot of intelligence-related information about the issue. And this type of information varies according to the issue's category. This is an open source security issue. So obviously we have here the vulnerabilities, and we show here the list of CVEs. And we are showing first the CVEs whose severity is the highest. We have here a node for the library, also very much relevant for an open source security, and information about the library. And also here the user can click the nodes to get more detailed information about it. And we have here nodes for compliance, and the user can click each of the compliance items and get more detailed information, standard the issue, the category, and the control. We have here also the items of the OSCAR frameworks and CWE items. As you can see, when we designed the attack path, we made sure that the user will have all the information required to understand and to triage the issue. And we made sure that he can get it in one page without the need for him to navigate between many tabs or many pages, but rather to have it all in a glance, and also to show first the things that are most important and relevant. For example, vulnerabilities, we show first the CVEs whose severity is the highest. Commits, we show first the latest commit, etc. On the right of the issue node, we have the node for the application. And here you can see the repo name. Here it's the famous juice shop repo. We see the business priority of this application. It's 100, it's very high. We see the main language of this repository. Here it's TypeScript, and the user can click the language node and see a list of all the languages that resides within this repo. we can see here a node which is called process data that lets us know that this repo processes PII and payment-related information. I would like to mention that what we are doing here by gathering all those information, business priority, the processing data information, soon I will also mention the APIs, this is actually creating a threat model of everything that impacts the application and the issue. And we will have in the near future also more webinars that will elaborate more about threat modeling. We also have here connected to the application a node which is called link to the app. If the user will click it, he will be navigated to this specific application in the Ox application page, where he can see even more information about this application. On the right of the application node, we have the nodes for the APIs which exposes this issue. And for each API, we can see the endpoint name, the endpoint method, the framework of the API, here it's Express.js, the file in which the API definition resides, and we have here, in this example, 2 functions. Those are the functions that are being executed when this API is invoked. And the user can click here, and per each one of those functions, you can see, of course, the name, and also a link to the location of those functions in the code in his repo. Above the API node, we have a button which is called call stack. And this button shows the function call stack between the API definition via the handler function to the location of the issue in the code. This type of information we at Ox call evidence, and which is actually the evidence that in this API exposes the issue and where the location in the code that it's defined and where the location of the issue in the code. All this information is helpful when AppSec team collaborate with development and R&D teams and need to understand together why this specific issue is important, required to be fixed, and where it needs to be fixed. For this specific issue, we have several APIs exposing it. So I'm scrolling down and even have like the +3 more that shows that there are even more APIs exposing it. We also have here a gray APIs node that its purpose is to give information about all the APIs in the repo, meaning also the one that doesn't expose the issue. And we have a link to the API bomb to see more information about those APIs. So now that we are done with the API nodes, on the right of it, we have the Amazon ECR, and I will hand over to Itai to continue the attack path demo from this point on. Itai, the floor is yours.
Thanks, Raviv, for the detailed walkthrough. And let me please share my screen. Okay, so as Raviv already mentioned, the attack path visualize the way that the code travels, that the issue travels from the code to the cloud. The first step, after we manage to show and to walk through the code information, is the image container. What we are doing is we match repositories into container images. In this specific example, you can see here that we found that this repository, Juice Shop, is built into an image with the same name, resides on this Amazon ECR account. And we also provide a link to the ECR console where you can see more details about the image. In this specific example, we have only one image that was matched to this application. But in the general case, repo can be built into multiple container images on multiple registries, and we will show all of them over here.
Itai, before we continue, I would like to mention that if any of you, our audience, have any question, please write them down in the chat. And by the end of the webinar, me and Itai will address some of the questions that will be raised. Please continue. Sorry for interrupting you in the middle. Yeah.
Yes. Okay. So some of the advantages of matching container images to repositories are more than what we show here in the graph. For example, we are able to match SCA issues where we found this vulnerable dependency both in the container and both in the code, and we match those two issues together, which allows you to solve both container issues and code issues in one place. This will reduce the amount of security issues that you will have to others. Second advantage is that by matching the repository to the ECR or to the image, we are able to have issue owners for container security issues that are based on the application of the repository, making the issue owner property more accurate. And the last advantage that I would like to emphasize here is that it allows you to better prioritize container container security issues based on the reachability. To the right, we have the Kubernetes, or in this specific example, EKS nodes, where we found this container image to be deployed as a workload. In this case, we have two clusters. One cluster is development cluster, and the second cluster is production cluster.
Itai, is this a common implementation to have two clusters the way that we see right now?
Yes, it's very common for our customer to use multiple Kubernetes clusters. Usually they use for development environment, staging environment, and production environment. You can have multiple clusters for each of the environment to use. So if you will click on the cluster information, we'll have its name, the cloud, the relevant cloud, the region, namespace, and the specific Kubernetes platform. In our case, it's EKS, with a link to the cluster in the relevant AWS console. To view the specific workloads that have this image part of it, we will expand the Kubernetes node, and we will get list of workloads. In this specific example, we have a Kubernetes deployment by the name Juice Shop with a link to the console that is using the Juice Shop image with this specific hash and tag. We also add severity factors to each one of the workloads. In this specific example, we are able to say that this workload has Internet Exposed API. It's also running in the Internet Exposed cluster, and it's a long-running workload. In case the workload has Internet Exposed API, we also provide information about the ingress that exposes it to the internet. You can see here the name of the ingress with the link, and also severity factors that are related to the specific ingress.
Itai, can you explain our audience what is the meaning of the icon that we just saw next to the data that you showed? In the right side, yeah.
This icon is used to copy the property information for when you want to share it with other teams, development or other application security members. You can just copy the property value and share it.
Yeah, cool.
Yeah. The ability to know which repo is built into an artifact that is running in a specific workload Kubernetes environment provides clarity, but it's also help or assist you to know if issues that were fixed are really reached to a production environment or are still waiting in dev or staging environment. So this is a really important capability for application security teams to be able to know or to track issue fixes along the pipeline. Those two Kubernetes clusters are part of an AWS, deployed in an AWS account. You can see the account ID, the DNS that is used to access those clusters from the outside, the region information, and if you will click and expand, we will have a list of load balancer that routes traffic into this Kubernetes cluster. If you click on one of them, you'll also get the DNS name as we saw before, and the listening port. Next to the Kubernetes cluster nodes and to the internet node, we provide network analysis information. In this case, we are able to say that this workload that is running in this cluster is exposed to the internet. This workload is directly exposed to the internet. In case the workload itself was not exposed to the internet, but another workload in this cluster was exposed, we will write that this is an internet exposed cluster. And before the internet node, we have a summary of the internet exposure of the overall issue. And in this case, this is an internet exposed issue. It's also exposed by an API, as Raviv, you mentioned before, and the workload is also exposed directly to the internet. Right to the internet node, you can find all the SaaS applications that are being accessed from the application. And if you will click on each one of them, you will have concrete evidence in code why we found this application or this SaaS service to be used by the application. If it is a dependency, if we import or if we actually use this SDK, we also provide this information if you use direct API calls and not through an SDK. So to summarize everything together, the graph offers a complete view of security issue from its origin in the code through the application, container image, Kubernetes workloads, exposed APIs, and internet exposure. This provides application security teams with comprehensive information for prioritization and important solid evidence for the development teams.
That's amazing. That's amazing. I want to add to what you mentioned, that here we see the SaaS services of this application, and to let our audience know that we also have a SaaS-born page that shows all the SaaSes across the entire organization in all the applications. We had a webinar about it about 3 weeks ago. We have the recording it in our website, and the SaaS-born feature is available to all our customers to access. Before we will answer a few questions, I do want to mention about our, let me share my screen again. 1 second. So Ox Security, we have an open PLG platform, which means that any of you, our audience, can go to the Ox Security website and either book a demo with us, or you can also start using our product for a free trial period. After you will start, you will click Start Free. You will need to create your account. You will be required to select your source controls, to start scanning them, and then you will get results of issues, and each issue will have a tab with the attack path. The attack path itself will show at the beginning, before adding more connectors, information about the issue, the application, the APIs as I demoed, and to view more information about the attack path, like the full attack path information that Itai showed, you need to define several connectors. Itai will mention like in a minute about what are the connectors required. I also want to mention that you can also start for free, and even without connecting your source controls, you can start by demo data and explore our platform and see how it works. Itai, can you elaborate more about the connectors which are required to have the full capabilities of the attack path as we have demoed?
Yes. Let me share again the screen.
Sure. I will.
So in order to get the full capabilities of the reachability issue to cloud information in the attack path graph, you will need to first connect your cloud deployment. In our case, it's what we presented right now. It's a AWS cloud. You will need to have your registry or use registries connected into Ox, and to connect your Kubernetes platform. In this case, it's EKS. We are currently have EKS as beta, and it will soon be open to all of our customers.
That's fantastic. We'd like to highlight again that before those connectors, you will still see the attack path tab, and you will see the basic attack path that I demoed. To see the full of it with all the clusters information and the cloud information, you will need to add the connectors that Itai has just mentioned. I see that we have a few questions. Let's answer one of them. You mentioned about the APIs exposing an issue. Can you elaborate more where else in Ox this kind of information is available? Sure, it's an excellent question, and I will share my screen again. So when I demoed the attack path, I described the API nodes, and here we have the APIs exposing the issues. And I also mentioned that we have all the APIs and the link to the API bomb page. But there is another place that I want to show you that shows the API information. I will close here, go back to the issue page. And on the right of the attack path, there is a tab which is called APIs. And here we also have a list of all the APIs that exposes this specific issue. So it's used for some people like looking at lists and grids, especially it's useful when the list is very long. So in addition to the graphical representation of the nodes in the graph of the APIs, we also have the APIs tab in the issues page. And let's go back to the attack path again. And I will open it again in a full page. And I want to mention again, we did 3 weeks ago a webinar about the API bomb. But since it was asked, I will also show again and say a few words about the API bomb page. I will click the link here. And just to remind you all, we are looking at an issue that is connected to a specific application, which is called Juice Shop. And when I will click the link here, I will be navigated to the API bomb page with the filter of the application, which is called Juice Shop. And here we can see a list of all the APIs in this application that were discovered by Ox. This includes APIs that exposes issues. And you see here those circles that represents groups of issues of severity. It means that each of those APIs exposes issues, and the user can click it and get to the issues page and see those issues. The user can also click the expose issue statistics and see the breakdown for each one of the endpoints about the issue that it's exposing. And everything here is clickable, and you can go and see them all in the issue page. We do show in the API bomb page also APIs that don't expose any issues, like those ones, because API bomb should give a visibility of everything that we discovered. It's supposed to prevent what we call shadow APIs, to give full awareness and visibility to the AppSec team about the APIs within their organization. I hope this answered the question. I see here another question. You have demoed a cluster with one workload. What will be the experience like if we will have a cluster with several workloads? Itai, would you like to answer this question?
Yeah, sure. Let me actually find an example.
Sure.
And I will share and show you. Just 1 second.
I think it's a good question because, not necessarily just one. You can have multi. So it's good that it was asked.
Okay, so as we mentioned before, we show the list of workload when you click expand on the Kubernetes cluster node. And here you can see in this example that I have 2 workloads. I have 2 different deployments, one with the name bank website deployment, and the other one with the name bank website deployment no service. You can see both of them here. One has exposed internet, is exposed to the internet, and the other one is not. If we add more, you will be able to scroll down and see all the relevant workloads. In general, in this specific case, is only one image that is running in void. But as we mentioned before, a repository can be built into multiple images, and then we'll have all the list of images here, and all the workloads that are belong to all of the images will be shown here in a list.
That's very cool, and I think it's an excellent experience because let's say you have a 3 or 4 or 5, you want the user first to see it in a more consolidated way, and then when he expanded to see a longer list of the things to make it like more usable and friendly for the user. I do want to show again, not again actually, I just mentioned it, I didn't show it, that I mentioned API bomb, Oh, and I said a few words about the SaaS bomb that were demoed in another webinar. I still want to show it again and let you know that we have in Ox the SaaS bomb feature that shows an inventory of all the SaaS services that were discovered by Ox. And we use this information also in the attack path, we show it. And we show it also in the organization level here. So it's very useful and important feature, this and the API bomb. So right now, so by the way, API bomb is also here under this menu. And we have also the bomb overview. It shows an overview about all the bombs. So we have right now reached the end of the webinar. And I would like to thank Itai who joined me, and also to you, the audience that participate in our webinar.
Also, thanks to Raviv.
Sure, no problem. It was a pleasure to me. And I hope that you also enjoy this webinar and that it provided a value to you. And I hope to see you in the coming webinars that we will do, and have a good night or good day, depending where in the world you are right now. So bye, everyone.
Bye. Thanks for joining.